Hey everybody, welcome to Zoo Science. My name is Cynthia. We've got a really cool thing to talk about today. When I say cool, I mean keeping it cool. That's the title of our program today. And we're going to talk about how color affects heat absorption and light reflection for us, for our animals, even for our planet. So have you ever walked outside on a hot, sunny day, barefoot on the blacktop and burned the heck out of the bottom of your feet? Because that blacktop gets really, really hot, doesn't it? But you jump up on the sidewalk where the concrete is much lighter and it's not as bad, right? I've done it. And that is what happens. Light interacts with an object when it comes, and it can either be absorbed as thermal energy, which is heat, or it can be reflected, kind of bounced off that object and sent back out into the universe, right? So the darker the color, like the blacktop, the more heat it's going to absorb. And the lighter colors reflect more heat, so they don't get as hot, right? I've got a cool experiment for you guys to try. I want you to do this at home when you have time. You'll need a couple of glass jars. I've got mine all set up over here in the interest of time. I kind of set it up in advance. Couple of glass jars or glasses. You'll need some white paper or fabric and some black paper or fabric, right? You'll need some water. I've already poured the water in these jars. You'll need a thermometer to measure the temperature, and you'll need a heat source. Now, the best thing would be a nice hot sunny day, but unfortunately it's a cold, chilly morning here at the North Carolina Zoo, but I'm using a heat bulb, a heat lamp, and that's fine. You can do that too. If you don't have that, you can just use a regular incandescent light bulb to provide some heat. You let it sit for a while, maybe a couple of hours. That's why I've already got mine set up. And after a while, you check the temperature. So if you can, Donna, zoom in a little bit. I'm going to check the one that's light first. What we'd expect is the white coloring surrounding this jar of water to throw back the light and not get as warm. So I don't know if you can tell, I'm seeing 73.6. Let's try it in the darker one. I've surrounded that jar with black fabric, and I'm setting it on black paper. Oh my goodness, it's going up, up, up. We have 89 degrees on the black one. So there you go. That's what happens, guys. Kind of cool, right? Now I have a question. Who's this? Anybody recognize this animal? It's a polar bear. If you're saying that, you're absolutely correct. Now, how does he stay warm in the Arctic, where it gets to be 40 degrees below zero if he's white? Or is he? Remember, I just told you, the darker the object, the more heat it absorbs, the more light it absorbs and turns into heat. So he doesn't appear black, so how does he stay warm? Well, what color is his fur? It appears white, and it needs to, because look at his background. He's got to blend in with his environment, right? So that he can camouflage when he's hunting. But his fur is not white, guys. Little secret, it's clear. Each individual polar bear fur is clear, or translucent is a big word for clear. Have you ever seen a single snowflake? Have you ever been out in the snow and maybe caught one just on your hand and noticed that you could see right through it? Yeah, individuals are clear. It's not until several get kind of stacked up on each other that they start to appear white. And the same is true with polar bear fur. But if you'll notice, take a look at this picture. Underneath all that fur is the skin. And I have a sample of real polar bear fur here. And if you pull the fur back, look at that skin. It's black. And that's how polar bears stay warm, or one of the adaptations they have for staying warm. That light comes through the translucent fur and hits that dark skin and is absorbed as heat energy, right? That is such a cool phenomenon. And in a way, guys, the same thing is happening to our planet. You may have heard of global warming. Well, the Earth is warming up. And unfortunately, what that's doing is causing some of the polar ice caps in the Arctic, where those polar bears live, to melt. So the ice is white, and there's less and less of the white to reflect the light back. And it's melting into the water, which is darker, and that darker color is absorbing more heat, right? So that's adding to heating up our planet. There's a big fancy science term for that called the albedo effect. It's a whole nother program we don't have to get into, but I just thought you might be interested to know. So that's what's going on with heat and light absorption and reflection. You guys try this at home. Try that experiment with different colors of paper, fabric, different colors of water, even different backgrounds, and see what you get. I'd love to know. Thank you for joining me on Zoo Science today. Can't wait to see you next time.